Ever wondered how tiny, precise plastic parts, like gears or bottle caps, are made? It all starts with injection molding. Hot, melted plastic is injected into a metal mold. Here's the twist. The finished plastic part is always smaller than the mold. This isn't a mistake. It's called shrinkage, and it's a fundamental part of working with plastics. When plastic cools, its molecules pack closer together, making the part shrink. Imagine a mold for a 100mm ruler. After cooling, the ruler measures only 98.5 millimeters. That 1.5mm difference is shrinkage. Every plastic part shrinks as it cools, and different plastics shrink by different amounts. Engineers must predict this and make molds slightly larger than the final part. This process is called cutting steel for shrinkage. By intentionally oversizing the mold, they ensure the cooled part is the perfect size. Without accounting for shrinkage, parts wouldn't fit or function properly. It's a small detail, but it's crucial for making reliable products. Shrinkage is the hidden science behind every perfect plastic part. Next, let's see how engineers calculate it. So, how do engineers know how much bigger to make the mold? They use a simple formula to calculate shrinkage. Shrinkage rate, percent, x, mold dimension, part dimension. Mold dimension, is 100. Using our ruler, mold is 100 mm, part is 98.5 mm. The difference is 1.5 mm. Divide 1.5 by 100 to get 0.015. Multiply by 100 and you get a 1.5% shrinkage rate. This percentage lets engineers design molds for any part size using the same material. If they need a 200mm part, they make the mold 1.5% larger. This calculation is the secret to getting perfectly sized parts every time. It's a simple step, but it makes all the difference. With this formula, factories can produce millions of identical parts. Now, let's see why controlling shrinkage matters so much. In factories, controlling shrinkage is everything. Consistent shrinkage means high quality and fewer defects. If parts shrink unpredictably, products won't fit together. Imagine Lego bricks that don't snap. Engineers monitor temperature, pressure, and cooling time to keep shrinkage stable. A stable process saves money and ensures products work as designed. When you buy something that just works, it's because engineers mastered shrinkage. It's the invisible science behind quality manufacturing. New to injection molding. Don't assume shrinkage is the same in all directions. It's not. Plastic shrinks differently along and across the flow, leading to warped parts if ignored. Wall thickness matters. Thick areas cool slower and shrink more, causing warping or cracks. Good design means keeping wall thickness uniform. Placing the gate, the entry point for plastic, in the wrong spot can cause uneven shrinkage. Sharp internal corners create stress and cracks. Rounded corners help prevent this. Don't blame the material for shrinkage problems. Unstable processes or poor design are usually at fault. Control temperature, pressure, and cooling for best results. The best engineers focus on process control and smart design. Avoiding these mistakes leads to better, more reliable parts. Shrinkage is a normal, predictable part of injection molding. It's not a defect, it's physics. Engineers use a simple formula to calculate and compensate for shrinkage. Most shrinkage problems come from unstable processes, not the material itself. Consistent process control is key to quality. Good design, like uniform walls and rounded corners, prevents most issues. Mastering shrinkage means combining smart design with precise control. That's how you turn a challenge into a manufacturing advantage.